Okay, let me start the lab experiment class. So you guys possibly listen and take lecture about the computer vision, which is uploaded last week. And we are going to implement and run object detection and the pose estimation with YOLO V8 in the jet rover, the robot you have. So briefly seeing what we are going to do, we are going to run object detection and object pose estimation. But regarding object detection, the YOLO already provides some well pre-trained model, so we can download and run right away in the robot. And regarding the object pose estimation, as the robot doesn't know about how the cube looks like, so we are going to collect data set manually and fine-tune the YOLO V8 pose model, and then deploy it to the robot and perform the visualization. So let's start from object detection. As we saw the last lecture, our YOLO node has a role like to get a RGB image from the running camera node and giving the inference result like the bounding box or some estimated pose to the other programs. So we are going to build this node. So what you have to do is first create the package in Rust2WS using those commands. And you should download YOLO V8 checkpoint with the command using this command. If you type this command in the terminal, you would download the pre-trained YOLO V8 model in that directory. So after making the package directory, go to that directory and then type this command. And also there is some Google Drive I uploaded in, you can check this lecture note. You can see some launch and YOLO detector directory, download and put it in this robot. And after making the package, you should modify some setup.py file. This line to make the Kekin know the location of launch file and each node's location. And after put that on, you should modify this YOLO detection node.py file. There is some blank that you should fill, like the path that the pre-trained model exists. And then after building with this command and run this command, you would run this kind of YOLO package node. To do that, you may run this depth camera launch file and also detection launch file, so that you should run the camera file and the YOLO file. Then you will see this object detection program. To see this, you should run this architect image program and then select the right proper topic like YOLO detector / detection image kind of topic. Then you can see the estimated result calculated in real time. That is the first activation we should do. And the second one is YOLO V8 pose fine-tuning. So to do that, you should take pictures of cubes manually and then collect data set to do that. And we are going to use this roboflow.com URL to collect and assign and label the data set. To follow those description, you should assign some labels to the images you collected. At project, name the class, and you should add some key points to predict for robot. And for predicting the cubes, you are going to predict the top side of cube like you did with the arc marker. So if there is a cube, the robot should predict the top side of top, right, left, and bottom point of them. To do that, after taking some photos you collected, drag and drop the images and save. And then you should manually label this dataset to match the original position of top side. To do that, go to annotate data, label with my team or label myself. So using this website, you can work assigning the cube dataset with your teammates. But you should know that as the RoboFlow free plan has limited 2 users per team, so if you guys have 3 team members, you should consider the other methods like working in shift of up to 2 people at a time or using a single shared account like a new Google account and then use it. And after assigning those data, you can make dataset format like split into train set, validation set, test set also. And then download dataset, YOLO V8, and show download code. You can see this download code and also copy snippet and open notebook. But you don't have to open new notebook file, but you should know this API key or this the workspace ID and the project ID to work in your notebook file. We've attached the Jupyter notebook file in our Google Drive in this lecture note. So open it and copy the collab file from the link and edit the code and run the file to see results and download the model checkpoint. You may need to collect your own data set for each cube and like 100, more than 100 images per one color of cube. And you should train this model. To do that, you should fine-tune some hyperparameters to find the model to work. After training is accomplished, running all of the Jupyter Notebook files, you can download the trained YOLO V8 post model on JetRover, and then fill some blanks like the path or the predicting function, editing YOLO post node.py and YOLO post.py. You can run the same way as the object detection did, like run the camera launch file, pose estimation launch file, and then view that image with RQT image view. And then you may see the predicted result of cube or the predicted pose of the cube properly. That is what you're going to do this week in lab experiment. For submission, you should submit the Jupyter Notebook file with remained logs. You can hide your API key because that can be used in wrong way, but please keep your workspace ID and project ID so that we can find and search your RoboFlow dataset to check whether you collected dataset well. And please attach 2 capture file, object detection and the pose estimation. You should capture the YOLO running screen. The inference result should include at least 1 person so that we can check whether you run properly and then see the result. And you can submit those 3 files using the email, this one, and please follow this title. Deadline is until this regarding the day. For Monday class, you should submit the next week, and for Tuesday class, you can submit the next May 12th. This is the end of presentation, and any questions regarding implementing or filling those codes? then please start from the lecture note following that.